going to talk about the structure of an atom, which should be reviewed for the most part. We've definitely talked about it a little bit in 7th grade, and I'm sure I know you heard it some in 6th grade. And then we are also going to talk about how to read an element block, which is not too difficult, and we've done before, but to make sure we understand that as we move on to reading the periodic table a lot more. First off, the size of an atom, just to get a general idea of how small atoms actually are, because obviously we cannot see them. You cannot see them with a microscope because they are so tiny. A penny contains 2 times 10 to the 22nd atoms. So all those zeros, that's how many atoms that a 1 penny has. So depending on the element you have is going to depend on the size of the atom. Now obviously if you have a hydrogen atom, it only has 1 proton, 1 electron, 1 neutron. It's going to be smaller than something that has 70 protons, and 70 neutrons, and 70 electrons. But even our biggest atoms, they're still way smaller than anything we could ever possibly see. There's actually now some studies done that there's something called a quark that is inside of an atom, and there's smaller particles, and we can get more into what exactly those are later, but those particles are even smaller than atoms are. In fact, I read the other day that there are 3 quarks inside of a hydrogen atom, and if you were to, each of those quarks were a size of a garden pea. So to show a proportion of how small a quark is compared to an atom, if each quark is the size of a garden pea, then the hydrogen atom itself would be 1,000 miles wide. So quarks themselves, a pea compared to 1,000 miles wide, is insanely small. So we are discovering more things as we get into the future. Obviously, your book doesn't quite mention that because the books are a little old, but so the atoms aren't really the absolute smallest thing because there are quarks inside, but atoms are still super tiny. For extra credit, I want you to write the word quark at the top of the page. So it's Q-U-A-R-K. Alright, the 3 particles of the atom, which again, hopefully we've got that pretty well down, but as a reminder, protons are positively charged, so positive protons. They are in the nucleus, and they are about 1 AMU, which stands for atomic mass unit. That's how big they are. A neutron is neutral, so it has no charge. It's also in the nucleus, and it's about the same size as a proton, so about 1 AMU also. And an electron is our negatively charged particle. Those are the ones that are flying around the nucleus in the electron clouds, and there are definitely our smallest particle of the atom. So it's close to 0 AMU. It has almost no mass whatsoever. So a lot smaller than our protons and neutrons. So just a picture here. I want you to fill in on your diagram so you know what is where. So we've got our neutrons and our protons inside of our nucleus there that you can see. We also have the nucleus labeled on the inside. And then those rings there are representing our energy levels within our electron clouds, where our electrons are flying around on the outside. Alright, I know your element block looks a little different than what mine does, but it's still for the same atom. The one that you have on your page, honestly, is a little more, I feel like, common setup of what you will typically see on our periodic tables, but either way, you should still be able to read one no matter how it's set up. So first, we're going to have our element name. So that's not always on the periodic table. I believe that ours in the book does have the name there, but again, it just depends on which one you're looking at. The atomic mass is going to always be on there, and that's just the average number of neutrons with an average number of protons, and it's basically finding the average mass of an atom. So we're going to talk about in the future here in a few days about how some atoms of the same element may have different numbers of neutrons. So they take all of those possible atoms, average it with the protons, and they get an average mass, and that's what the atomic mass is. The element symbol, so remember it's going to be a 1 or 2 letter symbol. There are some 3-letter ones, I guess, that we've discovered now, but 1, 2, or 3 letters, always going to be a capital letter to start, and then if there's a second or a third letter, then it's going to be lowercase. And then the atomic number is what tells us the number of protons inside of that element, and the number of protons is what identifies that element. So that's how our periodic table is ordered by atomic number. If it doesn't have the same atomic number, it means it's a completely different element. So the atomic number cannot change in amount. We've got number of protons is never going to change, like I just said, because the atomic number is not going to change, or else it'd be a different element. Our number of electrons can change if it is an ion, so we will talk about that. In the next couple chapters here, we'll talk about ions, and then we will talk about isotopes, which is when we have different number of neutrons within the same element atom. So we'll talk about those here in the next couple of days.